Hello. Um, this video is the fourth class of economic statistics course. We are entering into a new chapter. The second chapter is entitled as Conditional Probability. So it is closely related to the previous chapter, but it is a little more difficult and still very interesting. I believe you will find it interesting. So in the previous chapter, we learned just basics, how to define probability, how to define events, how to manipulate and basic operations on them, and the basic rule, like the addition rule. That's pretty much it. So they are important, they are basic, but frankly, there are not many not many new things, or you may be disappointed because it was too easy. So I guess you may have turned off uh, the video because it was too easy. That is true. So if you already know what's going on, it must be boring. But today it will be a little bit more interesting and new and more difficult. We are going to study the relationship among variables using probability. So in the previous chapter, there is no clear kind of purpose of the analysis. There was no clear example why we need to study this. Frankly, yes. But today you will see many examples because the topic is mainly motivated by the research questions and widely used in research questions. So it is easier to understand in that sense, but on the other hand, it is more complicated because it's complicated. And references actually are the same. In the textbooks, the conditional probabilities are in the same chapter as the general probability chapter. So I'm based on the same, this chapter is based on the same chapters as in the first one, but will be in more depth. Let's start with example. So our research question is, suppose that we are wondering if there is any discrimination against female police officers in their promotion decisions. So we would like to test it in using data. And suppose that we have a frequency distribution table. So in our data, there are many promotion candidate police officers, and we observe their gender, and we observe the result, whether they are promoted or not. So these numbers are the frequency distribution table, and we are going to use this data to answer this question. Of course, the numbers are fake, it's not real, and I'm not saying anything about anything about discrimination itself. It's just an example. So it's everything is fake. I'm not arguing that there is a discrimination, or I'm not arguing there is not. So just don't be political. Please just use it as an example, only as an example, not anything more than that. So let's think about this. So we first define a notation for those events, basic events. M stands for male and F stands for female. And P stands for promoted. And then automatically the complement negation of promotion is denoted last time we learned in the last chapter. We defined complement. P superscript C is the complement of event P, which means P does not happen, so it means not promoted. And in this table, can you calculate this? The probability of the intersection between F and P, female and promoted. So pause the video here and try yourself. And I am going to give you a second. And now I will show you the answer. If you're still trying, pause again. That's easy. The idea is we have 4 outcomes. So the sample size is sum of all the frequencies, sum of these 4 numbers. So in our data set, there are 1,200 candidates, 1,200 police officers. And among them, 288 are male promoted, and 36 is promoted female, and 672 are not promoted male, and 204 are not promoted female. So among 1,200, only 36 are female and promoted. So it's 3%. And then it is easy. Calculate this. And if you need practice, again, pause the video and try yourself. Okay, I'll turn the page. In the same way, it is easy only because the sample size is calculated. So we know that the total number of observation is 1,200. And among them, among 1,200, we are looking for these guys, male and promoted. So there are 288 male promoted police officers, which means there are 24%. There are 24% of promoted male, but we already calculated the probability of promoted female, which was 3%, and that of male was 24%. Then there is a big gap between these probabilities. Do you think like these numbers can be an evidence for discrimination? Can you argue that the probability is too high for male than the female? Think about this, and if you think yes or no, think about why. Why this comparison shows discrimination, or why not? It does not make sense. I will stop the video here, and I'm going to start another video by answering this question.